Hello everyone. Now let's start computing indefinite integrals. The first step to compute indefinite integrals is to, of course, look at basic formulas for indefinite integrals. And this basic list that I'm going to go through is basically the list of basic derivatives. If you know how to compute the derivative of a function, of course, if you have the answer of that function, if you have that derivative, then the family of antiderivative of that function is going to be your starting function plus c, because we know that adding a constant is not going to change the fact that this original function is a primitive. All right, so what is the set of all primitives for a constant k? Well, it's going to be kx plus c, because the derivative of kx plus c is k. So this is the way I like to think about these formulas. So because I know how to differentiate, I always think about these things going like from the right to left. Because the derivative of kx plus c is k, then the indefinite integral of k is kx plus c. Because the derivative of x to the power n plus 1 over n plus 1 plus c is going to be x to the power n, of course, this formula will not work if n is minus 1, because this would create a evil division by 0. Then we know that the indefinite integral of xn is x to the power n plus 1. So you take your power and you go plus 1 over that n plus 1 again plus c. Because we know that the derivative of the absolute value of x is 1 over x, then the indefinite integral of the function 1 over x is going to be ln of absolute value of x. Be careful with absolute values here, plus c. This is, of course, really dealing with the power function n equal minus 1. It has its own rule. What is the integral of ex? Well, because we know the derivative of ex is actually ex, then the indefinite integral of ex is going to be ex plus c. And by the way, if you're dealing with general bases, if you need to integrate a to the power x dx, where a is a strictly positive number, not equal to 1, you're going to get ax over ln of a plus c. So this is like the general formula if needed, okay, when you're dealing with other bases. All right, because we know the derivative of minus cos is sine, then the antiderivative, be careful with sine here. It's very easy to make mistakes. You're so brainwashed that the derivative of sine is cos. The indefinite integral of sine is minus cos plus c. Because we know the derivative of sine is cos, the indefinite integral of cos is going to be sine plus c. Again, here, be very careful with sine, because we know the derivative of tan is secant squared. The indefinite integral of secant squared is going to be tan plus c, because we know the derivative of cotan is minus cosecant squared. The integral of cosecant squared is going to be minus cotan plus c. Because the derivative of secant is secant tangent, the integral of secant tangent is going to be secant plus c. Because the derivative of cosecant is minus cosecant cotangent, then the integral of cosecant cotangent is going to be minus cosecant plus c. And some other creepier one that you might not remember, because the derivative of arctan is 1 over 1 plus x squared. The integral of 1 over 1 plus x squared is going to be arctan plus c. And finally, because the derivative of arc sine of x is 1 over the square root of 1 minus x squared, the integral of 1 over square root of 1 minus x squared is going to be arc sine plus c. Again here, it's the same basic list that comes from differentiation. It's just written in integral form. And in that basic list, there's only one formula that is typically shitty to work with, and it's the power rule. All the other ones are just formulas that you need to know, but the only one that you need to actually apply is what happens if you have a power function, because you need to label the correct power. So let's just do examples of basic integral dealing with power function, because these are the only examples we can work with initially. So what is the integral of x4? Well, x to the power 4, so my n is 4. I'm just going to write x to the power 4 plus 1 over 4 plus 1 plus c, which simplifies to x to the power 5 over 5 plus c. Again, one thing that is cool with integration is that you can always verify your answer by differentiation. If you compute the derivative of x5 over 5 plus c, you're going to get 5x4 over 5. The 5 will cancel each other, and the plus c, bye-bye, goes to 0. So it works very well. All right, what about the next example? Again, this is just like differentiation. Just make sure you know how to label your power correctly. 1 over x4 is actually a power function where the power is minus 4. And now I can apply my rule. So I get x to the power minus 4 plus 1 over minus 4 plus 1 plus c, which simplifies to x to the power minus 3 over minus 3 plus c. And if you're really in the mood, you can even simplify this a little bit further as minus 1 over 3x to the power 3 plus c. Finally, for the fourth root, or 1 over the fourth root of x, that's the same thing as the power function, x to the power minus 1/4. Now you apply the power rule, so you get x to the power minus 1/4 plus 1 over minus 1/4 plus 1, which is 3/4 plus c, of course. So you get x to the power 3 over 4 over 3 over 4 plus c. You can leave the answer like this, or if you want to be a little bit creepy, this simplifies to 4 over 3, fourth root of x cubed plus c. Here we go. So, and when you look at the basic list of integrals, only the power rule is the one where you need to think about something. All the other ones are just the formulas themselves. All right, that's it for those basic integrals. But of course, basic integrals come with what? They come with basic properties. So typically when you're dealing with a function, you're not dealing with like a pure ex or a pure sine x or a pure x to the power 3. You're dealing with a function that is such that its equation is a combination, an algebraic combination of those basic terms. So either by multiplying these terms by coefficients, by adding them, subtracting them, multiplying them, putting them in quotient or combine or doing composition. Well, the basic property says that if you have two functions, small f and small g, and you know how to compute their primitive respectively, let's say they're called big F and big G, then the integral of a times small f plus b times small g will be a, that coefficient, times big F plus b times big G. Okay, so it's just, you can really go term by term algebraically, and this is not going to change anything. All right, so let's just do some examples together. So let's compute the indefinite integral of the function 5 minus 2ex plus 3 over x. So we're just going to go term by term. So we want to compute the integral of 5 first. So 5 is just a constant, so we know it's going to be 5x minus the integral of 2ex, because the integral of ex is ex, we're going to get minus 2ex. So we just keep the coefficient. We turn the ex into we turn 2ex into 2e. Oh my god. What about the next term? 3 over x. That's the same thing as 3 times 1 over x. So you're going to get 3 ln of the absolute value of x. And when you're done, you sign with work with plus c. All right, let's do now the indefinite integral of 3 cos of x plus 5 sine of x. So we want the integral of 3 cos. Because the integral of cos is sine, the integral of 3 cos will be 3 sine. Now let's integrate sine of x, 5 sine of x, because the integral of sine is minus cos. You're going to get minus 5 cos of x, and then we're done. We just go plus c. Now another one, a little bit more complicated, but of course if you have that list, it's not too bad. So we want to compute the integral of 2 secant squared minus 3 cosecant x cotangent x. Because the integral of secant squared is tan, the integral of 2 secant squared will be 2 tan of x. And because the integral of minus cosecant of x cotangent of x is cosecant, the minus 3 will just become plus 3 cosecant of x. And when you're not sure, especially with sine, always think about these questions the other way. Take your answer, compute its derivative. You're going to get, if it's done correctly, you're going to get the integrand, the equation in your integral. All right. right, next, let's compute the integral of 6x cubed plus 5x plus x to the power 2/3, which is the same thing as the cubic root of x squared, plus 4 plus 2 times x to the power minus 1/4. So if you take the fourth root, which is powering by 1/4, and you bring it up by changing the sign, the power is minus 1/4. So this is just 5 terms. Going to use, for most of them, the power rule. So here you're going to get 6x to the power 4 over 4, because 3 plus 1 is 4, plus 5x to the power 1 plus 1, which is 2, over 2, plus x to the power 2/3 plus 1, it will be 5/3, the new power, so over 5 over 3. The integral of 4 is going to be 4x, and if you take x to the power minus 1/4 and you go plus 1, you're going to get x to the power 3 over 4 divided by 3 over 4. And you can keep your fractions on there, I don't care, okay, you don't need to simplify, and that's the answer. That's the full family for that function. So you just go term by term, you keep your coefficients, everything is gonna be all right. Now for our last example in that section, let's integrate 5 over x squared plus 5 over 1 plus x squared plus 7 over the square root of 1 minus x squared. So here it's just a question of making sure you know the distinction between using the power rule or something else. So 5 over x squared, that's a power function where the power is minus 2. 5 over 1 plus x squared, be careful or not, you cannot just go to the denominator and play with it. This is simply 5 times the function 1 over 1 plus x squared, which is of course the derivative of arctan. And 7 over the square root of 1 minus x squared is the same thing as 7 times 1 over the square root of 1 minus x squared. And that function, 1 over the square root of 1 minus x squared, is the primitive for arcsine. So when you're going to compute big G, or the general family of antiderivative, well, you're going to get minus 5 times x, not minus 5, sorry. You're going to get 5 times x to the power minus 1 over minus 1 plus 5 times arctan plus 7 times arcsine. And then when you're done, you just go plus c. And if you're really in the mood of simplification, then you can maybe bring the negative power down, the minus up. So poof, this could be like the simplified version of that question. Typically, I don't really care when the question is just about computing families of antiderivatives, but just in case, okay? So you should be able to see the equivalent formulation for answers. All right, for that section, that's it. That's all. Bye-bye.